This video will cover the introduction for the most recent lesson in Algebra 2 over the synthetic division algorithm. Again, I promised you that I would teach you synthetic division as a shortcut for division with a binomial. Because polynomial long division is not the most enjoyable process in the world. It's actually kind of lengthy and can be very confusing. So synthetic division is a shortcut for polynomial division, but it only works when we are dividing by a binomial of degree 1. It only works for binomials in the form x minus r. So here's an example of one that does work, and we will jump right in. That's the way to go through synthetic division, is just jump right in. Now our divisor is in the form x minus r. So if you look, since this is minus r, this would mean that r will always have the opposite sign of what's given in the problem. In this case, r would be positive 4. So the setup for this involves placing that r value in what I call the box. Okay, so r goes in the box. Now next to the box on the same line, we are going to put the coefficients from our divisor or our dividend. So the coefficients starting with 2x to the third is 2. The x squared term has a coefficient of negative 13. The x term has a coefficient of 26. And the numeric term is negative 24. So we write just the coefficients. Now we got lucky here, but we need to keep in mind that we must still have our terms written in descending order, and we must still have every single term. They must all be there, okay, just like long division. So we leave one line of space to show our work, and we draw a line to separate our work from our answer. Now the way the synthetic division works is we're doing all the same work we did for long division without any of the variables, so it removes a lot of the guesswork. So what we do is we drop down this first term. It doesn't matter what that number is, we bring it straight down. Then what we do is we multiply that number by our r value. In this case, we're going to go times 4. 2 times 4 is 8. We write that underneath the next number. Then we add down. Negative 13 plus 8 is negative 5. We're going to repeat those same exact steps until we run out of numbers. So we're going to multiply negative 5 by 4. Negative 5 times 4 is negative 20. Then we add down. 26 plus negative 20 is 6. Then we're going to multiply 6 by 4, which would be positive 24, and we would add down to finish the problem, which is 0. Now this last number is your remainder, always. But in this case, this would indicate that there is no remainder. Okay? Now, the numbers that we have down here below the line, 2, negative 5, and 6, are the coefficients on your solution polynomial, your quotient, your answer. And since we're dividing an x cubed polynomial by an x polynomial, our answer will start 1 degree less than x cubed. So 1 degree less than x cubed would be x squared, which means the 2 is the coefficient attached to x squared, 2x squared. The 5, the negative 5, would be attached to an x to the first power, and the 6 would be the numeric term. So our answer here is 2x squared minus 5x plus 6. Now if there were a remainder, we would add that to the end exactly like we did for long division. So if there were a remainder, we would write plus 0 over x minus 4. But there is no remainder, so we will cross that bridge when we get to it. So here are two more examples we're going to use for synthetic division. Again, this is in the form x minus r. So we should right away recognize that this means r is equal to 2. So we're going to put 2 in the box. And outside the box, we're going to put our coefficients, starting with our largest degree term. So 3 is the coefficient for the x cubed term. Negative 8 is the coefficient for the x squared term. 11 is the coefficient for the x to the first term. And negative 14 is the numeric term. That's all the terms we need. We're not missing any terms, so we don't need to deal with that wrinkle yet. Leave one line of space, draw a line. Bring that first number down, which is 3. 2 times 3 is 6. Add down is negative 2. 2 times negative 2 is negative 4. Add down is 7. 2 times 7 is 14. Add down is 0. So this indicates again that there is no remainder. So we still will not have to deal with how to deal with that. Again, we started with x cubed, we divided by x, so our answer should start off with x squared. So it's 3x squared minus 2x plus 7. And there's no remainder, so we don't need to deal with that yet. Our answer would be 3x squared minus 2x plus 7. Example B here has a couple of the wrinkles that we need to know how to deal with. First of all, r would be negative 2, because it's always the opposite of what's shown. That says plus 2, so r is minus 2. Now the other thing to notice is that we do not have an a cubed term, so we need to put a 0 between the 4 and the 2, at least in our heads. So when we go to do this, r goes in the box, that's negative 2. And our coefficients would be a to the 4th is 4, a to the 3rd isn't there, so we need to put in a 0, a squared is 2, a to the 1st is negative 4, and the numeric term is 12. Leave one line of space for the work, draw a line. Bring the 4 straight down. Negative 2 times 4 is negative 8, add down is negative 8. Negative 2 times negative 8 is 16, add down is 18. Negative 2 times 18 is negative 36. Add down is negative 40. Negative 2 times negative 40 is positive 80. Add down is 92. So again, that is your remainder, which means we get to deal with that this time and see how that works. So again, our problem started with a to the 4th. We divided it by a to the 1st, so our answer should start 1 less than 4, which would be a cubed. So our answer is 4a cubed minus 8a squared plus 18a minus 40. And then our remainder of 92 becomes the top of a fraction, and the bottom of the fraction is our divisor, a plus 2. So our final answer would be 4a cubed minus 8a squared plus 18a minus 40 plus 92 over a plus 2. So that's 3 good examples of basic synthetic division. Now, I said before that synthetic division only works when you're dividing by a binomial in the form x minus r. So the question arises, well, what do you do if your divisor is not an x minus r form? So here's an example where we have a number in front of x, which means it is not in the proper form, because the proper form always has a 1 in front of the x. Well, we can actually trick this problem into allowing us to use synthetic division. In order to turn 3x into 1x, I'm going to divide by 3. But the rules of mathematics say that if I'm going to divide that term by 3, I actually have to divide every term in both polynomials by 3. So that's what I do. I divide everything by 3. Now the other thing to notice is that we're missing a numeric term, so we have to add a 0 to the end of this polynomial. So this problem is really going to be 1x to the 4th minus 5/3 x cubed plus 1/3 x squared plus 7/3 x plus 0 divided by x plus 1/3. And now we've taken the problem that wasn't in the correct form, and it is now in the correct form with an r that is negative 1/3. So ladies and gentlemen, this would be the point in the class where what I've been telling you all year becomes true. You cannot avoid fractions in Algebra 2. These fractions cannot be turned into decimals or you will get the problem wrong. So you need to get over your dislike of fractions and use them. So negative 1/3 is my r, that goes in the box. Outside the box I have my coefficients. 1, negative 5/3, 1/3, 7/3, and don't forget the 0. You have to have it or the problem will not work out. First number comes straight down, that's a 1. 1 times negative 1/3 is negative 1/3. Add down. Well, negative 5/3 plus negative 1/3 is negative 6/3, which reduces to negative 2. Negative 2 times negative 1/3 is positive 2/3. Add down, that would be 3/3, or 1. Negative 1/3 times 1 is negative 1/3. Add down, that would be 6/3, or positive 2. And 2 times negative 1/3 is negative 2/3, which means when I add down, I have a remainder of negative 2/3. So in a way, it wasn't that bad. The fractions actually kind of eliminated themselves other than the remainder. So we do have to talk about how to deal with the remainder. Now, just like before, we're going to apply the same rules to attach variables to these coefficient numbers. So we started with x to the fourth. We divided by x, so our answer should start at x to the third. So we have 1x to the third minus 2x squared plus 1x plus 2. And then the remainder is problematic because our remainder would be 2/3 over x plus 1/3. And this is mathematically inappropriate. We are not allowed to leave fractions within a fraction. If they were decimals, we wouldn't be able to leave them there either. So what we do is we're going to multiply just that term by what would be the common denominator, 3, over itself. Now, the reason we're doing this is because that will eliminate those fractions, but multiplying by 3 over 3 is multiplying by 1. And multiplying by 1 doesn't change the value. So what that does, and by the way, we're also going to write these two terms without the coefficients because technically that's better math notation. X cubed minus 2x squared plus x plus 2. And then our remainder, 2/3 times 3 is 2 over 3 times this binomial would give us back our original dividend, or divisor, 3x plus 1. So our answer would end up being x cubed minus 2x squared plus x plus 2 minus 2 over 3x plus 1. Let's do one more example of this, and then we'll cut this video off and do the last two examples as a separate video. Okay, so here's the next example. 8x to the fourth minus 4x squared plus x plus 4 divided by 2x plus 1. Two things we should notice right away. We do not have an x cubed term, so we're going to have to put a 0 x cubed in here. And we're going to need to divide everything in the entire problem by 2. Now I know what you're thinking. What about the 0? Well, what is 0 divided by anything? It's still 0. So it doesn't matter if you put the 0 in before you divide or wait till after you divide to put in the 0. Either way, you'll still have a 0 in that spot. So you should end up with 4x to the fourth plus 0x cubed minus 2x squared plus 1/2 x plus 2 divided by x plus 1/2, which means our r value is negative 1/2. So r goes in the box, negative 1/2. It's your r value that goes in the box. And then outside the box, 4, 0, negative 2, positive 1/2, positive 2. Leave a line of space for work, draw a line, drop the 4 straight down. Negative 1/2 times 4 is negative 2. Add down is negative 2. Negative 1/2 times negative 2 is positive 1. Add down is negative 1. Negative 1/2 times negative 1 is positive 1/2. Add down, that's 1 because that's 2 halves. Negative 1/2 times 1 is negative 1/2. Add down, that would be positive 3 halves for your remainder. Again, now if you're struggling with why that is, remember that 2 is 4 halves. So 4 halves minus 1/2 is 3 halves. So we have 4x to the third minus 2x squared minus 1x plus 1 plus 3 halves over x plus 1/2. So again, we cannot leave the remainder as that kind of fraction. So we need to multiply it by 2 over 2, which again will cancel those fractions without changing the value because we're multiplying by 2 over 2, which is 1. So our final answer would be 4x cubed minus 2x squared minus x plus 1 plus 3 over our original divisor, 2x plus 1. We'll cut off the video here. I'm going to do the other two examples as a separate video in case you don't quite get it yet.